Okay, number 5. Okay, so here we have a motion problem. A particle moves along the x-axis according to the position function. S of t is equal to t cubed minus 12t squared plus 15. First we have to find v of t and a of t. So v of t, that's velocity. The velocity is the derivative of the position function, s of t. So let's just take the derivative. So we have v of t is equal to 3t squared minus 24t, and that's it. The derivative of a constant is 0. So this is the velocity function. Now a of t, the acceleration, is the derivative of velocity. So a of t is equal to 6t, the derivative of 3t squared, 6t minus 24. Now here it says find the velocity and acceleration after 1 second. So we just have to substitute t equal 1. First we'll substitute into v. Substitute t equal 1, and we have 3 minus 24, which is minus 21. And a of 1, just substitute in 1, we have 6 minus 24, which is minus 18. Okay, in part C, find the position. Find the position. Now remember, position, that's s. Find the position when the acceleration is 0. That's when a of t is equal to 0. So first we have to figure out when is a of t equal to 0. Let's do part C down here. Alright, so we're going to solve a of t equals 0. Here's a of t right here. So we'll do a of t, which is equal to 6t minus 24 equal to 0. Okay, add 24 to both sides. We have 6t is equal to 24. Divide both sides by 6, and we have t is equal to 4. That's 4 seconds. Alright, we didn't finish answering the question yet, because the question is find the position when a of t is equal to 0. That means find the position when t is equal to 4. So finishing our question, we have to find s of 4. Here's s. We're going to substitute into this function right here. Okay, so we have s of 4 is equal to t cubed, that's 4 cubed, 64. That's 4 cubed minus 12 times 16. Plus 15. And that comes out to minus 113. Okay, in part D, we're asked, when does the particle change direction? Alright, so when the particle is going in one direction to the right, then the velocity is positive. And when the particle is going to the left, that's in the negative direction, then the velocity is negative. So the particle changes direction when the velocity is 0. That's when it changes from positive to negative, or negative to positive, when the velocity is 0. So let's write this when v of t equals 0. So that's what we have to figure out. When is v of t equal to 0? So let's look at that. Let's look at part D. Let's do it over here. So we're going to solve the equation v of t equals 0. Now we're asked when, so our answer is going to be a value of t, a number of seconds. Okay, so v of t is 3t squared minus 24t. So we see it up here, 3t squared minus 24t. Let me copy it down here. All right. Well, let's see. We can factor out a 3t to solve this equation. That might help. So we have 3t, and we're left with t minus 24 equal to 0. So we get two solutions. T equals 0. Well, that's when the particle starts moving, so that's not what we want. T equal 24, that must be when the particle changes directions. So that's the solution. Okay, in part E, we're asked, when does the particle return to its initial position? What is its initial position? Well, position is S, remember? Initial means t equals 0. So its initial position is the value of S of 0. Now let's look at S. Here's S. We substitute in 0, we get 0 minus 0 plus 15. So S of 0 is equal to 15. So that's its initial position. So we're asked, when does it return to its initial position? So we want to know, when is S of t equal to 15? Okay, when, like that is for what t value? Not including the initial position, because we want to know when does it come back to that initial position. So this is what we have to solve. S of t is equal to 15. Okay, so let's write that down. Here's S of t. S of t is t cubed minus 12t squared plus 15. And when is that equal to 15? Well, just subtract 15 from both sides, and we have t cubed minus 12t squared is equal to 0. And factor out t squared, and we have t minus 12 equals 0. So the solution is t equal 12 seconds. So after 12 seconds, the position is again 15 units.